Okay, welcome year 10s to this video. As you can see, we are looking at solving quadratic equations in this topic. The topic itself is going to cover a range of different skills to do with quadratic equations, but we're going to start off with something that you have done a little bit of in year 9, and it is going to draw on some of your factorising skills as well that we have already covered this year, so it's going to be a good review of some of those skills. So just as a reminder, what is a quadratic equation? If you have a look at the equation that I've drawn just here, obviously no numbers in this one, just pronumerals, but you're looking for a term that has a power of 2 when you are looking at a quadratic equation, as opposed to a linear equation where the highest power will be a 1 on the x term. So we've got ax squared plus bx plus c. What you're going to notice with when we start to solve these is, of course, they need to be equal to something for them to be an equation. So with this one here, a general form that you might see is that this is equal to 0. And that's actually what you're going to first try and do when you come across solving quadratics, is you're going to try and equate them to 0. The reason is, well, we're going to look at this particular method of solving, which is via factorising. We do want it to be equal to 0, and there's a range of different reasons for that, but the main one I want you to think of is the particular skill that we're going to be looking at, and that is the null factor rule, and that's something that you did do in year 9. Null obviously meaning 0. So first step will be to make sure your equation is equal to 0. So that might mean doing a little bit of rearranging to get your terms on the left-hand side so that you just have a 0 on the right-hand side. The second thing that you will be doing after that is factorising. So this might be via difference of 2 squares or just a standard monic factorisation, or of course we have non-monics as well. That's when your a term, the coefficient up here is not 1. So that's done a little bit differently. So a bit of a review of that in this video. And finally, we're going to use the null factor rule to solve. Now what that means is when you've got a product and it's equal to 0, so I'm just calling the product m times n. Now remember that you could have 2 brackets being multiplied, you could have an x term multiplied by 1 bracket, lots of different things could be represented by the m or the n, but basically you've got 2 numbers being multiplied together. Now, if that is equal to 0, what that means is either this m is 0, either the m is equal to 0, I should say, or the n is. There's no other way for us to get this product equal to 0 if one of these numbers is not equal to 0. So one of these has to be equal to 0. Of course, we could have a case where both of them are in fact equal to 0. So, or both equal to 0. We're going to work on the presumption that just one of them is, and I'll show you how we write that in our answers as well when we're solving. We're actually going to get 2 answers. A lot of the time we're going to get 2 answers for these. So either m or n equals 0. Of course, we will have lots of different things there, either brackets or x's or different pronumerals. So I will show you what I mean by doing a few examples. Okay, so I'll just get to my next page. Here we go. I'll start off nice and easy. Here we've got x squared minus 4x equals 0. So you'll see all the terms are already on the left-hand side. We've already got it equal to 0 or equated to 0. So what I'm going to do now, my second step, is to factorise. You'll see that I do have a common factor in this left-hand side of the equation, common factor of x. So I can factorise like so, and then of course that is equal to 0. And now what I can do is say, well, if x times by x minus 4, so if I'm using my pronumerals before, it's like calling this m and that term there n. If that's equal to 0, then one of these that's being multiplied has to be 0. What I'll say now is either x equals 0, so either this is 0, and that one there, it wouldn't matter. Obviously it's the same number, but this number out here must be 0, or what's in that bracket there must be equal to 0. So x minus 4 must be equal to 0. So, just finishing up, obviously this is simplified. If x minus 4 equals 0, that means x would be equal to 4. So see how we've got two possible answers here. X is 0 or it's 4. Now if you put it up here, what you should find is that it works if we substitute back into the rule. So if x is 0, that's 0 squared minus 4 times 0 is 0, yes. And if we put the 4 in, 4 squared 16 minus 4 times 4 is 16, 16 minus 16 is 0, so it works. So you can see how there's two possibilities for this. Now moving down to one that looks a little bit different. Here we've got our full quadratic with all three terms that we generally see. And what we need to do, obviously it's already equated to 0, we would need to then factorize this. So this is a little bit of a review of factorizing. Now this is of course a monic because we've got a coefficient there of 1. Don't need to write it in, of course. So what I need is two numbers that will multiply together, so their product is 12, but then they add to give me the 8, a positive 8. So not a difficult one because, of course, factors of 12 that add to 8, 6 and 2. Next step is one of these in the bracket here, one of these terms, the x plus 6 or the x plus 2, one of them has to be equal to 0, or both of them, of course, for this equation to be equal to 0. So what we say is either this one, x plus 6 equals 0, or the x plus 2 equals 0. We don't leave it there because we want what would the x value be. We say so x is equal to negative 6 to make that 0, or it could be negative 2. Now, of course, we can check this one again. If we put, say, I'll go with the negative 2. If we put the negative 2 back up into this rule here, or that one there, you'll see that that one will equal to 0. You should get 0. So if we check that down, negative 2 squared is 4. 8 by negative 2 is negative 16. So that would be 4 minus 16, negative 12, plus 12 is 0. So it does work. And you can do that the same with your x is equal to negative 6 if you wish. Okay, so obviously they will get a little bit, you will come across a variety of different problems. So I do want to tackle just a couple of different ones if that's okay. Here we've got one, x squared minus 25 equals 0. So it doesn't look exactly the same as the ones that we've done so far. And this one, in fact, we have a couple of different ways that we could go about it. Now, if I do it the first way, which is via factorising, because that is basically what you'll do with pretty much all of these. This one's just a special one because there is a slightly different way. If I was factorising this, what I would notice is this is a difference of two squareds problem. You'll notice that it's in this form. Of course, where the b value is 5, because 25 is a perfect square. So what I do is I first recognise, and of course this is actually an x here, what I do is I first recognise that yes, I do have a difference of two squares, or dots. Now of course that means that I can factorise really easily because, just switch colours, difference of two squares factorisation, we go plus b minus b, which in this case is 5. So that will then leave me to finish it off. I can say that for this to be equal to 0, x plus 5 or x minus 5, they will equal to 0. And then we get an answer of x is equal to negative 5 or it's equal to positive 5. Now, this can be done a different way, of course. If we have x squared minus 25 equals 0, because this is a square number, if I add 25 to both sides, I get this. And what I can do then is take the square root of both sides. And when I take that square root of 25, I do actually get two answers. Positive 5 squared will be 25 and negative 5 squared will be 25 as well. So this is why I get two answers here. And that will be, of course, the same, and I might just copy it, as what I've got here. No, that did not work. Okay, never mind. X equals negative 5 or positive 5, which is basically what I've written there. I've used just a little plus and minus symbol, which you will start to see a little bit more of in this topic. Interestingly, this doesn't, that's what I pasted before. It's gone all the way down there. I'll get rid of that. Now, interestingly, you look at this and you think, oh, great, I can do this exactly the same way. Obviously not with dots because it isn't a dot, so it doesn't have a subtraction symbol here. But if I try and do this, I'll subtract 25 of both sides this time, we do come into a problem, and this is something that will happen with quadratics due to graphically what's going on. Sorry, I'm just going to change that. If I try and take this square root of a negative number, that's not going to work. We don't have a solution for this, so we simply just need to write this has no solution. And all that means graphically is that that particular graph, the x squared plus 25, doesn't actually pass through the x-axis at all. So this will never actually equal to 0. Well, for no x value will it equal to 0. So there's something that can happen, just so that you're not alarmed if you come across that. That is possible. There will be a couple of different ones. Now, all of the ones we've done so far, they've all been equal to 0, or they've all already been rearranged in that way. So I just want to show you a couple where they have not been rearranged, or they're not in the right form just yet. So just make that point. Ensure they're rearranged. Take all your terms over. Make sure they're rearranged to the left-hand side of the equation when you are solving. And I'll show you what I mean by that here. As you can see, I've got x squared equals 9x. So if I rearrange by subtracting 9x from both sides, you'll see I'm left with 0 on the right-hand side. From there, I will factorise. There we go. And that's equal to 0. Now just be careful here, don't divide both sides by x. Of course that is possible to do at this point, but then you'll lose one of your solutions. So we leave it like this. Once we've got a number multiplied by another equal to 0, we can then solve using null factor law. So in this case, either x is 0, so it is similar to one of the first ones that we did, or x minus 9 is 0. So, of course, we have x equals 0 or x equals 9. This one over here, again, we want to make sure we've got everything on the left-hand side. So first I will subtract 5x from both sides, and in the same step I will add 6 to both sides. If you need to do that in an extra step, you might like to. So we've got everything on the left-hand side, it's equal to 0. It is a monic, so because this is a 1 here, so we can do it the standard factorization of a monic. Two numbers that multiply together to give us positive 6, but add to give us negative 5. So we're going to have two negative numbers here. Two negatives will give us this positive 6, but they'll add together to give us this negative 5. So it looks like we're going to need the 3 and the 2. So that means x minus 2 or x minus 3 equals 0. So then, of course, x equals 2 or x equals 3. There we go. Okay, now just before I finish, there are a couple more that I just want to touch on because we do need to be careful. Obviously, when we're factorising, we need to be careful of this. And when you are obviously solving via factorising, you also need to be careful of this. Sometimes when you come across some problems, they will have a common factor. And you need to make sure that you simplify to either remove that common factor, I guess, in a way, so that you can solve appropriately. What I mean by that, I'll show you with this one a couple of ways. With this one here, we could do it the same way that we have done previously. So that's to get all your terms onto the left-hand side. Just make that more clear. Equating it to 0. Once we've got this, we want to make sure that we take out common factor, because you'll see that there is a common factor here of 4x. That would be x minus 3. Now here, null factor law, again, either 4 times or 4x is 0. That would mean that the x is 0. Or the x minus 3 is 0. Leaving us with our answer of x is 0 or x is 3. Now, alternatively, you can actually divide both sides by 4 to begin with, once you notice that common factor. So what I mean by that is, as you can see, if I've got a common factor on both of these coefficients, if I divide both sides by 4, I'm actually left with x squared equals 3x. So what I've done is divided that by 4, divided that by 4. Then just to make it easier, you'll see I'm going to get the same result, so it really doesn't matter too much, but it is something that sometimes just speeds up this process a little bit because you've got much nicer numbers to work with. And then I'm going to get the same result. X equals 0 or x equals 3. So I just wanted to show you that that can be done. You can divide both sides by that common factor to simplify things. One where this is really important is this one. Oh no, not that one. That's not what I was ready for. Into number 5. Oh, there it is, just at the bottom of the page. One where it's really important to look for your common factor is something like this, because you might look at it and go, oh, it's one of those non-monic ones. I'm going to have to do that whole A times C process. But with this one, you actually don't, because you should recognize that this 4 goes into 8, 4 goes into 140 as well. So as soon as you come across one of these, you see a non-monic here, you should always first check for a common factor. I want you to get used to doing that. Always check for a common factor before you start. So the common factor here was 4. So we're going to take that out. We're going to factorise that. Now 4 into 140, if I halve it, I get 70, and I halve it again, I get 35. Okay, so now that I've done that, if I divide both sides of this particular, so I divide that by 4, and I divide this by 4, so the whole thing by 4, you'll notice this will cancel out, and this is just going to be equal to 0. So what I'm left with is what's in that bracket there, being equal to 0. It's a little bit of null factor law as well in a way, because obviously the 4 is not equal to 0. So what's in this bracket has to be equal to 0 for this whole expression to be equal to 0. Once you've done that, you'll notice now we have a lot easier task at hand, because now we have a monic that is equal to 0. We need to factorize it, so two numbers, two factors that will multiply to give us negative 35, but will add to give us 2. I'm thinking of 7 and 5, so I'm thinking positive 7. And 7 take 5 will give us the positive 2, and multiplying these together will give me the negative 35. And we're nearly there, because x plus 7 must be equal to 0, or x minus 5 must be equal to 0. So we have x equals negative 7. Oh, I can't go down any further, so hopefully it's not getting cut off. Or x equals positive 5. Okay, one last one, and that is when we do actually have a non-monic. So what you'll notice with this one is my first step will be to notice, okay, I don't have a coefficient of 1 on this first term here, on the x squared term. So I would then check for a common factor, which I can't, or I don't have, because straight away my 5 doesn't go into 17, 17 which is prime. So straight away I'm thinking now I have to factorize using my non-monic method. Now there's a few different ways to do this. One of the ways that we went through in class was to multiply a by c first. So this number multiplied by that one. So you get 30. We then want two numbers, two factors of 30 that will add to give me the 17. So it's all positive, so 15 by 2 is 30, and 15 plus 2 is 17. What I will do from there is I will write my expression, but with this middle term split, using these two numbers as the coefficient of that middle term. The 6 term stays there, and that's all equal to 0, obviously. Make sure you've got it equal to 0. And then I will factorize via grouping. So I'll just have a look at this first section here, the 5x squared plus 15x. Well, that's got a common factor of 5x. Then I'll look at this second section here that has got a common factor of 2. So as expected, I've got a common bracket here. I'm left with 5x plus 2 by x plus 3. That's equal to 0. So just like I have done previously, 5x plus 2 must equal to 0, or x plus 3 must be equal to 0. So we will have to solve this one here. So 5x equals negative 2, x equals negative 2 on 5, or x equals negative 3. Okay, as you can see, there's quite a range of different things that you can come across. So you are going to have to ask yourself a few questions when you come across a particular problem. You want to look for your equation being equal to 0. If it's not, you need to rearrange it. The second thing you want to do is then factorize. Look for common factors. Look for dots. Decide whether you're working with a monic or whether you're working with a non-monic. They're the sorts of things that you should be asking yourself when you first come across these problems. Lastly, null factor law, and make sure you clearly write your answers at the bottom. X equals whatever you've got is your first answer, or x equals and then your second answer, because you will likely have 2 with a lot of these. And also remember, if you've got a square root of a negative number, that can't be done, so you have no solution. All right, thank you very much, Year 10s, for your time, for watching this video, and please make sure that you bring your questions to class.